welcome to The Explainer. Today we're going to dive into the world of numbers, but not to do a bunch of math, nope. This is all about learning the art of interpretation. We're going to build you a mental toolkit so you can see right past the flashy headlines and figure out what the data is really trying to tell you. So let's kick things off with a story. The author of our source material tells this great one about being in his high school calculus final. And look, he admits he hadn't exactly been paying the most attention in class. He's staring at this exam and nothing, not a single thing looks familiar. It's not just hard, it's like it's written in a completely different language. So he does the walk of shame, goes up to the teacher, and basically surrenders. But then, this amazing thing happens. Another student whispers something to the teacher, and she announces she gave them the second semester exam by mistake. Can you imagine the relief? And that feeling, staring at something that should make sense but is just utterly confusing, is something a lot of us have felt with statistics. They're literally everywhere. Sports, politics, the news, but the subject itself can feel so inaccessible, maybe even a little boring. It makes you wonder, right? If this stuff is so vital, why does it so often feel like it was designed to trip us up?
Well, this explainer is our answer to that question. We're not about to start doing complex calculations. Instead, we're building a toolkit for critical thinking. The goal here is to learn how to spot misleading numbers, how to ask the right questions, and how to uncover the real story that's usually hiding in the data. Okay, let's get into it.
First up, descriptive statistics. Now, don't let the name intimidate you. These are just the simplest numbers we use to summarize information. But as we're about to see, the simple choice of which number to show someone can take a story and turn it completely on its head. All right, let's put you in a scenario. Imagine you're at work. Your boss comes over with some warranty data. They want you to compare your company's printers to your biggest competitors. So you run the numbers. You get the average, the mean number of problems. And oh boy, the results are not great. Your printers have an average of 3.1 problems, while the competition's only at 2.8. On paper, it looks like you've got a serious quality problem.
But wait, before you panic, you decide to look at the median instead. Remember, that's the number smack dab in the middle of all your data points. And just like that, the entire story flips. Your median number of problems is just 1, while your competitor's is 2. Suddenly, your typical printer actually looks more reliable. So what on earth is going on here?
This is the crucial takeaway. Your company doesn't have a massive quality issue across the board. What you have is a lemon problem. See, a handful of really bad printers with a ton of defects were skewing your average way up. Those extreme outliers inflated the mean, but the median, which isn't really affected by those outliers, told the true story. For the most part, your manufacturing is solid. You just need to find out where those lemons are coming from.
Okay, so descriptive stats help us get a snapshot. But what about finding out what causes what? Now we're going to shift gears from just summarizing data to actually finding the relationships hidden inside it. This is where we get to put on our detective hats and start hunting for clues in the numbers.
Let's think about one of the biggest public health questions of the 20th century. Does smoking cause cancer? You can't just run a perfect experiment, right? You can't ethically force one group of people to smoke and another not to. And you can't just say compare smokers and non-smokers at a high school reunion. Why not? Well, because those two groups probably differ in a lot of other ways, like diet or how much they exercise. And there's another huge problem, selection bias. The unhealthiest people in the class, including those who have already passed away, are the least likely to even be there.
So how do we solve a puzzle like this? The tool is called regression analysis. The best way to think of it is like a statistical detective's magnifying glass. It's a powerful technique that lets researchers mathematically control for all those other messy variables, like diet, exercise, family history, so they can isolate the one specific relationship they care about, like the one between smoking and cancer. It's how we find the signal in all that noise. All right, now that we've seen some of these amazing tools, let's talk about how they can be twisted and misused. Let's do a quick-fire round of some common statistical shenanigans that people use, sometimes on purpose, to try and mislead you.
First trick in the book, always pay attention to the unit of analysis. For years, Verizon and AT&T had this huge advertising war built entirely on this idea. Verizon would claim it had better coverage and show you a map of the US that was mostly their color, because they were focused on square miles of land. Then AT&T would fire back saying it covered 97% of Americans, because they were focused on where people actually live. Were either of them lying? Not technically, but they were telling two very different stories by measuring two totally different things. Which of course brings us to this classic line from Caddyshack. It perfectly illustrates the whole apples and oranges problem. Comparing golfers by height is ridiculous. It's funny in a movie. But believe me, in the real world, these kinds of mismatched comparisons happen all the time, especially when there's money involved. For example, Hollywood just loves to release these lists of the highest-grossing films of all time. And if you look at a list like this one, you'd probably think that all the biggest blockbusters in history came out in just the last 20 years or so. You've got Avatar and Titanic up top. Even Shrek 2 is hanging out in the top 5.
But hang on a second. This list is comparing dollars from different decades without mentioning one absolutely crucial factor: inflation. A movie ticket back in 1939 cost what? 50 cents? Today you're looking at 15 bucks, maybe more. So, is it really a fair fight to compare a dollar earned back then to a dollar earned today?
No way! It's not fair at all. When you adjust for inflation, when you convert everything into today's dollars, the whole list gets completely rewritten. The real domestic box office champion? Gone with the Wind. Star Wars and The Sound of Music shoot right up to the top. And what about Avatar? It plummets all the way down to number 14. See? It's the same data, just presented in a much more honest way.
Okay, for our last section, let's take this a step further. We're going beyond just spotting tricks and into the realm of true statistical thinking. And this is all about learning to challenge our own intuition. Because when it comes to probability, let's be honest, our gut feelings are very often just plain wrong.
And there is no better example of this than the famous Monty Hall problem. The setup is so simple. You pick one of 3 doors. Behind one door, there's a brand new car. Behind the other 2, there are goats. Now the host, who knows where the car is, opens one of the doors you didn't pick to show you a goat. And then he asks you, do you want to stick with your original door, or do you want to switch to the other closed door? What do you do?
Now, your gut, like almost everyone else's, is probably screaming that it's a 50-50 shot now, right? 2 doors left, 1 car. It shouldn't matter if you switch, but your gut is wrong. The math here is undeniable. You should always switch. Switching literally doubles your chance of winning that car, from a 1 in 3 chance to a 2 in 3 chance.
So why? Why does switching work? The absolute key is that Monty's action isn't random. He knows where the car is, which means he will always open a door with a goat. So think about it this way. When you made your first pick, you had a 1 in 3 chance of being right. That means there was a 2 in 3 chance the car was behind one of the other 2 doors. By opening one of those doors to reveal a goat, Monty isn't changing the original odds. He's actually giving you new, powerful information. He's concentrated that entire 2 in 3 probability onto the one door he left closed. So, you switch. And all of this really leads us to one profound idea, which is captured perfectly in this quote. Yeah, it's easy to lie with statistics, but it is so hard to tell the truth without them. Without these tools to play detective, to make fair comparisons, and to challenge our own instincts, finding the real truth is almost impossible. So, from now on, the next time you see that shocking statistic in a headline or a claim in an ad, you're ready. You've got the toolkit. You can stop and ask, are they using the mean or the median? Are they comparing apples to oranges? Is my gut feeling here actually right? You now have what it takes to find the story the numbers are really trying to tell you.